MRI or magnetic resonance imaging. This is the topic of discussion in today's lecture. Magnetic resonance imaging. This is the full form of MRI. In diagnostic centers, you will find this machine. Okay, doctors often prescribe to go for such tests, means the tests which are done by MRI machines. This is nothing but imaging machine. Yes, X-rays are used to take images. Again, CT scans are there. Purpose is same, to take images. But in case of X-rays and CT scans, radiations are used. Whether it is non-ionizing radiation such as X-rays. Again, in case of CT scans, you know that ionizing radiations are used. But in case of MRI, no radiation is used. So that is good for the patients, because whenever radiation is used, to some extent it harms the patient's body. Means it is harmful to the body of the patients. So in case of MRI or magnetic resonance imaging, no radiation is used. So here the topic of discussion is how this system works. Okay. So in case of MRI, there is a large magnet which can produce constant magnetic field. Okay. Usually superconductors are used to build such magnet. Okay. To produce such magnet, superconductors are used in most of the cases, not in all the cases. And the field strength, means magnetic field strength, is of the order of 1.5 Tesla to 3 Tesla. Okay. And in some cases, means in case of research centers, they use normally magnetic field strength of 7 Tesla or more. Okay. But in case of clinical MRI means those which are used for medical imaging purposes. So in those cases, the magnetic field strength varies from 1.5 Tesla to 3 Tesla. So what is the procedure? So in the setup, in the equipment of MRI, there is one large magnet which can produce constant magnetic field. And the patient's body or the patient is kept inside that machine. Okay. And you know that human body is composed of mainly water, 70% water is there. Again, body fat is there, and fat contains also hydrogen atoms. Means there is abundance of hydrogen atoms in human body. And in most cases we are talking about water. Okay. And you know that hydrogen atoms have only one proton in the nucleus, not more than one. Hydrogen atoms have only one proton in the nucleus. And these protons are having some spin. Okay. So, and due to the presence of this spin, there is a magnetic moment of the protons of the hydrogen atoms. So when the patient is kept inside the MRI machine, so the magnetic field of that MRI machine influences the magnetic field of the protons which are contained in water. Okay. So what happens? There is a change in the alignment of the protons. Okay, in our body, there is a change in the alignment of the protons, because we are applying magnetic field to the patient's body, and due to that thing, this happens. Okay, noise is coming from outside. Please ignore that noise. Anyway, so what happens? So for some time, magnetic field is applied to the patient's body, and along with that, RF signals. RF means radio frequency signals, or radio frequency pulses are sent for some time. And when the RF pulses are turned off, when the radio frequency pulses are switched off or turned off, in that case, the protons, they tend to move their original position. Okay, and during this movement, during this realignment of the protons, they release RF signals, the protons, because they there was an induction of magnetic field to the protons, and that's why the change in orientation was there. One more thing I need to say here, and that is most of the protons align in the parallel direction of the magnetic field, means externally applied magnetic field by the MRI machine, and less than that make their orientation in the anti-parallel direction. And this phenomenon can be analyzed or can be explained by the help of quantum mechanics. You know that according to quantum mechanics there is a lower energy state, higher energy state. Most of the protons do stay in lower energy state, and less protons do stay in the higher energy state. And the protons in lower energy state, they align in the parallel direction with the magnetic field vector, okay, or in the direction of the magnetic field, and less amount of protons, less number of protons align in the anti-parallel direction, means just opposite direction to the parallel, that is called anti-parallel direction. So there is a net moment means magnetic moment, net magnetic moment in the direction of the magnetic field, means when the magnetic field was applied, okay. So now I am talking about during the relaxation, means when the radio frequency pulses are turned off. In that case, there is a phase of relaxation of the protons, and during this relaxation phase, due to conservation of energy, okay, the protons emit radio frequency signals, and these emitted signals are captured or recorded by the MRI coils, means coils kept inside the MRI machine. Those are called MRI coils. So these signals are captured, okay, and those signals are analyzed by using complex mathematics such as Fourier transform. First, Fourier transform of the received data is made, then one mapping is obtained, which is called K-space. Then again reverse Fourier transform is done on the same data, and ultimately the data required for the reconstruction of the image is obtained. Okay, so complex mathematical algorithms are involved in this process. So signals are received by the coils of the MRI, and those signals are processed mathematically using computers, you know that thing. Not manually, using computers, those things are processed. And if you integrate with this AI, that is artificial intelligence technology, then it will be superb. Anyway, today in many clinical centers, AI assisted, means MRI integrated with AI, that those equipments are also used, those facilities are also there. Anyway, this is a common imaging technology nowadays for capturing images of the bones, joints, muscles, liver, kidney, brain, means I am talking about tumors, okay, cancers. So for various diseases, for various problems, this this MRI technology, MRI imaging technology is used nowadays. So main focus of this lecture was to discuss about the technology of MRI machines, okay, which technology is used by the MRI machine to for the reconstruction of the images. Okay, so this was all about today's lecture. This is the end of this video. Thank you for watching this video.